Hi, in today's tutorial, we shall look at the mole. The mole is defined as the number of carbon atoms in exactly 12 grams of pure carbon 12. Mass spectrometry which count atoms very precisely have determined this number 6.22 times 10 to the power 23 atoms. This number is called the Avogadro's number. Avogadro's number. So one more of something consists of 6.022 times 10 to the power 23 units of that substance. So this simply means one mole is equal to 6.022 times 10 to the power 23 atoms or particles, anything. Particles could mean atoms, molecules, ions, neutrons, anything. So one mole of something consists of this number. Just as a dozen eggs. Dozen eggs is 12 eggs. One more of eggs or a mole of eggs is 6.022 times 10 to the power 23 eggs. So now let's look at an example on how we can use Avogadro's number. Also, we need to take note of this relationship. 6.22 times 10 to the power 23 AMU. AMU, this is atomic mass unit, is equal to 1 gram. Then also 6.022 times 10 to the power 23 atoms is equal to 1 mole. So make sure we need to know these two relationships. Now let's look at an example. We see how we can use the Avogadro's number. Example, compute the mass in grams. In grams, compute the mass in grams of a copper sample. Copper sample containing 25 atoms. Solution. First of all, we need to calculate the mass of 25 atoms. So we say also mass of copper, the atomic mass of copper, that is 63.54 AMU. This is the atomic mass of copper. Then now let's calculate the mass of 25 atoms. So we say 25 atoms times 63.54 AMU over, we want the atoms to cancel, so over 1 atom. So that will give us, we need to multiply. So 25 multiplied by 63.54, which is giving us, we have 1,588.5, so the atoms will cancel, AMU. Now we've gotten the mass of 25 atoms. Then now let's calculate the mass in grams. In grams, we have we know that 1 gram is equal to 6.022 times 10 to the power 23 AMU. Then now we can use, we shall use the dimensional analysis to calculate the grams of copper. We have 1588.5 AMU, then multiplied by, we want the AMU to cancel, so this one should come down. So we'll say times 1 gram, then over 6.022 times 10 to the power 23 AMU. As you can see, the AMU will cancel. So we'll simply divide this number by the Avogadro's number. So we'll divide by 6.022 exponential 23. This is giving us 2.664 times 10 to the power negative 21 grams. So this is the mass of copper in grams. Okay, so that is how we can calculate. So now let's look at the molar mass. We can now look at molar mass. A substance molar mass. A substance molar mass is mass in grams of 1 mole of the substance. So that is how we can define molar mass. In this case, the units of molar mass is grams per mole, simply G over MOL. We know that mole is equal to mass over molar mass. This mass is in grams, then the molar mass is in grams per mole. So this simply means that in short, we can simply say M over MM, that is mole. So in this case, it means molar mass, we can make the molar mass the subject of the formula. So in this case will be molar mass, MM, that is molar mass, is equal to mass over mass in grams over mole. So that is the formula if we are to relate it to the number of moles. Then now we can calculate the molar mass of a substance or a compound. For example, sodium hydroxide. So we use the masses, the mass number. From the periodic table we know sodium, the mass number of sodium. So here we only have one atom of sodium. So we have 1 times 23. So that is 23. Then the oxygen, we also have 1. Oxygen, the mass of oxygen is 16. So we have 16 there. Then hydrogen, we also have 1 hydrogen here. The mass of hydrogen, that is 1.008, 1.008. Then now, when we add it will now give us the molar mass. So we have 16 plus 23 plus 1.008. So we have 40.008 grams per mole. So the molar mass can help us also to calculate the percentage composition of compounds. So now let's look at percentage composition of compounds. We shall make use of the molar mass. So let's look at percentage composition of compounds. The two common ways of describing the composition of compounds. Number one, we can determine the percent composition of compounds in terms of the number of its constituent atoms. Then two, we can also use percentages by mass. That is the common way. Percentages by mass of its elements. So these are the two common ways, but normally percentages by mass is the one that is widely used. For example, we can determine the percentage of each element in a compound. So let's take, for example, ethanol. Example, we shall look at ethanol. Ethanol. The formula for ethanol is C2H5 OH. Okay, so now we can calculate the percentage of carbon, hydrogen, and oxygen in ethanol. So what we are going to do now, we first calculate the molar mass of ethanol. In this case, we have carbon here. There are 2 atoms of carbon. We have 2 moles of carbon. So 2 moles times the mass of carbon, that is 12.01 gram per mole. Then here we have 5 plus 1, that is 6 moles of hydrogen. gram per mole. So here we are calculating the mass, the molar mass of ethanol. Then oxygen, we only have one more times 16 gram per mole. As you can see, the moles will cancel, will simply remain with the grams. So when we multiply and add, we'll find that the molar mass of ethanol, it's giving us 46.07 grams. So that is the mass of ethanol. Then now we need to calculate the mass of each element in this compound. We can start with carbon. So now we'll say mass of carbon, percent mass of carbon. Percent mass of carbon is equal to, so we'll take note of this monomers. Percent mass of carbon, 46.07 grams. So percent mass of carbon is equal to mass of carbon in 1 mole. In 1 mole ethanol, over mass of 1 mole of ethanol. Mass of 1 mole of ethanol. So here we are dealing with the masses. So we need now to calculate the individual masses of the elements in ethanol. C2H5OH. So we can start with the mass of carbon. The mass of carbon, we have 2 times 12.01, which is giving us, so this is 2 moles times 12.01 gram per mole. So this is giving us 24.02 grams. The moles will cancel. Then mass of hydrogen we have 6 times 1.008 gram per mole. So this is giving us 6.04 grams. Then the mass of oxygen, we have 1 more oxygen times 16 gram per mole. This is giving us 16.00 grams. So now we shall use these masses to calculate the mass of the individual elements using this formula. So we'll start with the carbon. Percent mass of carbon is equal to mass of carbon over the mass of the compound. So in this case we have 24.02 grams over 46.07 grams times 100. So this is giving us 52.14. So we have 52.14%. Then we go to, let's find out the mass of hydrogen using the same formula. For hydrogen, percent mass of hydrogen, the mass of hydrogen, that is 6.04 grams over 46.07 grams times 100. So when we compute, we are getting 13.13%. Then the percent mass of oxygen, the mass of oxygen, that is 16.00 grams over 46.07 times 100. This is giving us 34.73%. So take note, so these are the masses for the individual elements found, the percent masses or composition of the individual elements found in this compound ethanol. So note that the percentage, the total percentage must add up to 100%. So we can simply add 52.14 plus 13.13 plus 34.73. So when we add, it will give us 100%. So this one is just used to check that our calculations were correct. So that is all for today's tutorial. In the next tutorial, we shall look at empirical and molecular formulas. We shall see how we can determine the empirical and molecular formulas from a known compound. Thanks for watching.